with experiment 2, which is about chemical and physical changes. Make sure you have a good view of the tabletop. From this experiment, we have 5 different things. The first one is NaCl. We have Na2CO3. We have magnesium sulfate, MgSO4, ammonium chloride, H4Cl, water, and a couple of unknowns. So I've kept all the solutions. They're all in their label sheets already. So you can just follow along with the report sheet. We're starting with part A, which is the reaction matrix. Our first reagent is going to be silver nitrate. For each of these, I will show you what the test solution looked like before, and then I'll show you what it looks like after I add the reagent. Okay, so let's get started. Our first test solution is sodium chloride. Sodium chloride is a clear and colorless solution. I'm about to add some silver nitrate, AgNO3, and we'll see what that looks like. Okay, I don't know if you can see this. Here's the result. Here's what sodium chloride and NaCl looks like in combination with AgNO3. So someone tell me, how would you describe what you see right now? Don't all go at once. What color is this?
White.
It's white. Is it a solution or a precipitate?
A solution.
Well, I can see some solid. I don't know if you can see it. There's some solid floating at the bottom. I don't like to find it because they're solid for all throughout. So it's not a solution, but a precipitate. So that's the kind of mixture that we call it. Not a solution, but a white precipitate. So that first row in table 1, where NaCl and AgNO are set, you are intended to write your observations in that space. For this one, you can write that you see white precipitate forming. You can abbreviate precipitate with PPT, because I know that square is pretty small. And you can just write like PPT, because that's what we see here. Now, the formation of a precipitate is a chemical change. That means that those two substances reacted together to form some new substances. And a chemical change is just one kind of change that can happen. We could have a physical change, such as melting, freezing, boiling. And we can have other observations like bubbling that would indicate the presence of gas. Or we could have a change in temperature where the cube would feel those types of changes. This one don't always see the, you don't see any bubbling. There's no gas being formed. There's no odor coming from this. It's just a chemical change that's indicated by the light. All right, let's go across that row. Continuing to react with silver nitrate. Our next test solution is sodium carbonate, Na2CO3. Now it was clear and colorless, but hopefully you can see as I add more AgNO3, it's changing color. And this is our final, but this is what the mixture looks like. Again, how do we describe that? Is it a solution or a suspension? Sorry, I couldn't hear that.
A solution.
Is it a solution if we have a solid forming, and the solid is pressed through it?
Would it be a mixture?
Well, a solution is a type of mixture, and there are other types. Now, solution, the word solution is that one can dissolve into another, right? Solute dissolved into a solvent. And if it was dissolved, there'd be no solid left, right? It would be all liquid. And because it's aqueous, you'd be able to see right through it. But this one, it is not transparent, not clear. I don't know how close I can bring this to show you that the solid settling at the bottom. And if we look at it, it's not transparent. The solid dispersed all throughout it. So that doesn't seem like a solution. This would be another precipitate, yes? And so I believe someone said earlier that it's white. I can see that white color settled at the bottom. So again, for this observation, for the reaction between sodium carbonate is Na2CO3 and silver nitrate, which is AgNO3. Your observation would be that a white precipitate was formed. So you could write white PVC right there. It's kind of hard to hear. Okay, yep, I've had this problem. So I'm trying to find a balance between not being too close to the speaker, but also showing you close enough what I'm seeing here. Okay, I'm about to write these first two results in case you couldn't hear me. So in the chat, I've written the two observations that we've made so far. Again, if you can't hear me, you can unmute and say something, but I'll be checking the chat occasionally between each part of the experiment, okay? And if you have any questions, let me know. You can go back, I can slow down, I can speed up, okay? All right, let's keep going across that first row of that first table. Our next solution is magnesium sulfate, MgSO4. This is what it looks like on its own. It is a clear and colorless solution. Clear because I can see right through it. It's completely transparent. And colorless because there's no color to it. There's no tint. There's no shade of blue or green or pink or anything. So this is a clear and colorless solution. Let's add some silver nitrate and see what happens. All right, have a look and tell me, is this a solution or a precipitate?
Solution.
Yes, a solution. And how would you describe it? Is it clear? As in, can you see right through it? Is it transparent and clear?
Yes.
Yes. Is it colorless?
Yes.
Yes. Now I don't see any change in temperature. I don't feel any change in temperature. There's no odor coming from it. I don't see any bubbling of gas. So your observation for this one would simply be clear, colorless solution, or something along those lines. No precipitate was formed here, so you can't write precipitate here. All right. Okay, so once again, this is the resulting mixture from combining magnesium sulfate with silver nitrate. All right, moving on. Our next solution is ammonium chloride, NH4Cl. On its own, as you can see, it is a clear and colorless solution. Let's see what happens when we add silver nitrate to it. Wow. Okay, here's the result. I don't know if you can see if I bring it up close, but there's some white solid again settling at the bottom. And to me, this white color looks a lot more milky than the first two that we saw. So again, since there's solid at the bottom and solid dispersed through it, that clearly is not dissolved, would we call this a solution or a precipitate?
A precipitate.
Very good. So for your observations here between NH4Cl and AgNO3, you can write, for example, milky white precipitate or cloudy white precipitate, whatever terminology fits the description that you're seeing. Okay? All right, I'm gonna put this down and repeat that in the chat for anyone who maybe could not hear me. The last one. Oh, why you hear me? All right, are we good to move on? I hope so. All right. Still moving from left to right across the first row of the first table. Our next test solution is water. Hopefully we all know what water looks like. And let's see what happens when we add silver nitrate to water. Oh, I think my water is a little contaminated. All right, I think my water is a little contaminated in this test tube. There should be no change here. So what you should be seeing here is a solution of silver nitrate. Remember our reagent solution of silver nitrate from this bottle that I've been dropping from? It's an aqueous solution, meaning the only thing in it is silver nitrate dissolved in water. So when I add it to more water, I'm not expecting anything to happen except that the solution will become more diluted. Does that make sense? In other words, if you add water to a solution, it should not magically form a precipitate. All water can do is change the concentration of whatever solution you're adding it to. So for this one, again, you can write no change. We started with a clear and colorless solution, and we still have a clear and colorless solution. So no visible change that we can observe. All right, that's for water. Still going left to right across that first row of the table, we have an unknown test solution. This is what it looks like. Have a look at it before I add silver nitrate to it. All right. Nice. Okay, here's the resulting mixture of the unknown and silver nitrate. Again, would you call this a solution or a precipitate?
Precipitate.
Very good. I can see solid dispersed through it. It's not transparent because I can't see all the way through it. And let me see if I can bring it close so you can see there's some solid that's sitting at the bottom of the tube as well. Hope you can see it. All right, so here we formed another white precipitate with white sediment at the bottom during the reaction between our unknown and silver nitrate. All right, I'm gonna put it down and go ahead. All right, any questions before we move on to our second reagent? Remember, you're going to need all your observations in order to determine which compound is in this unknown and the next unknown. So if you have any questions, please ask. I'll be happy to answer, okay? If not, let's move on to our second reagent, which is sodium hydroxide. So we're going to go through those same those same 6 test solutions, but this time we're reacting them with sodium hydroxide. All right, let's start off with sodium chloride. Sodium chloride, which we also know table salt, on its own is clear and colorless. Let's see what happens when we add sodium hydroxide. All right, do y'all see any change?
No.
No, it looks the way that it did before. Okay, so no visible change here. It doesn't feel warmer or cooler. You don't see any gas forming, any bubbles or effervescence. There's no odor coming from it. There's no precipitate formed. So no change here. All right, the next one, sodium carbonate. Let's add some sodium hydroxide and see what happens. All right, do y'all see any change? I've added the sodium hydroxide to sodium carbonate. Does it look any different?
No.
No, it
ma'am.
doesn't. Very good, very good. Okay, can anybody give me a possible explanation for why you wouldn't see any change when you react sodium carbonate with sodium hydroxide? What kind of reaction would be taking place if there was any? Considering they're both ionic compounds. Any ideas? Do we think maybe a displacement reaction? Do y'all think that's possible?
Yes.
Yes, okay. So in that displacement reaction, what ions would be exchanged? We have sodium paired with carbonate and then sodium paired with hydroxide. So when those ions are displaced, when they're exchanged, do we get any new compounds? Or do we have the same combination of ions in solution? What do you think?
The same combination.
The same combination, yes, because they have the sodium ion in common. So even if, let's say, there's one sodium ion that used to be with a carbonate ion, and it leaves the carbonate ion and goes and grabs a hydroxide. And then the sodium ion that used to be with that hydroxide leaves the hydroxide and goes and takes the carbonate ion. Well, we still end up with sodium paired with carbonate and sodium paired with hydroxide. Nothing has changed. No new compounds have formed. So we're not expecting to see anything. I hope that makes sense to everybody. But basically, when they have an ion in common like this, you're not going to see any visible change, even though on the ionic level, there might be some exchange. All right, I hope that's clear to everyone. Just trying to help you sort of predict when to expect a change and when not to expect an observable change. All right, let me write this down for you. Oh my goodness. All right, moving on. Again, stop me if you have any questions at all. Okay. So our next test solution is magnesium sulfate. Let's see what happens when we add sodium hydroxide. All right, here's the result. Now I don't see any solid sinking at the bottom, but how would we describe this mixture? Is it a solution or a precipitate?
Precipitate.
Very nice, yes. And what color would you say this is? Anyone?
A milky white color.
Yes, I'm seeing a very pale white as well. So milky or cloudy or pale white, whichever word feels right to you. To me, this white is not as, how you say, I don't want to say thick, but like vibrant, you know? It's a real pale white. All right, so that's your observation for that one. Okay, next one. We have ammonium chloride. Let's see what happens when we add sodium hydroxide. Okay, here's the result. Now we've seen this a bunch of times so far, so I'm sure you know how to describe this in your observations. From where I'm standing, I don't see any visible change at all. Would y'all agree?
Yes.
Yes, yes, very good, thank you. Very, very good. Okay, so this one's NH4Cl, ammonium chloride, combined with sodium hydroxide, NaOH. Right, so let me write those two in the chat for you real quick. Oh. All right, I hope we're good to move on. Our next test solution is water. Remember what we said about water? When you add it to a solution, a stable solution, it is just going to dilute that solution. It's just going to decrease the concentration of that solution. So what do y'all expect to happen when I add sodium hydroxide to water? Do you think you're going to see a precipitate?
No.
No, no. It should look exactly the same unless there's something contaminating the water, right? So let's go ahead and prove that prediction. Shaking to make sure everything's thoroughly mixed. Someone just got unmuted. Okay. All right, so we were right. No visible change. When you add sodium hydroxide to water, you just get a weaker solution of sodium hydroxide. So no change to be seen here. Now we're on our unknown, the same unknown. Let's see what happens when we add sodium hydroxide. Okay, here's the resulting mixture. To me, it looks the same as before. Yes, do you all agree?
Yes.
Yes, okay. So for that last column in the second row of this table, where you have your unknown reacting with sodium hydroxide, your observation is nothing. Nothing happened, no visible change. We ended up with a clear, colorless solution. All right, that's it for this part reacting with sodium hydroxide. I'm about to write these last two in the chat, but if you have any questions before we move on to the third reagent, you can unmute and let me know or put it in the chat and I'll address it when I see it. Okay. Oh my God, it did it again. Okay, that's the water one. Unknown. Oh my. Um, 1 minute. All right. Yeah, do you have your lab? You have your lab phone? Sorry, 1 minute, everyone.
Professor, your mic is muted.
I know, I just need 1 minute. A student just walked in and I'm trying to get them settled, okay? Just give me 1 minute.
Okay.
Thank you. All right, we're ready to go. So we're on to our third test, our third reagent, which is hydrochloric acid, HCl. So we're still on that first table in the third row, going across the third row, right? Our first test solution is sodium chloride. So let's see what happens when we add some HCl to it. A little more. Okay, here it is. This is the resulting mixture from the combination of NaCl and HCl. Is there any precipitate formed here?
No.
No, I don't see any other visible changes. And just like before, is there a common ion between NaCl and HCl?
The chloride.
The chloride. So even if these two compounds exchange ions, we're going to end up, like I said before, with the same combinations, right? So no new compounds have formed. So we're not expecting any change. If it was soluble before, it would be soluble after. So if it was a clear colorless solution before, it'll be a clear colorless solution after. And that's what we're seeing, okay? You guys are doing so great. All of our predictions have been correct so far, and I hope everything's making sense. If you have any questions, please let me know and I'll answer them, okay? All right. Moving across that third row. Our next test solution is sodium carbonate, Na2CO3. Let's see what happens when we add some hydrochloric acid. We don't have H. No problem. So we're on the third row where the reagent is HCl. All right, this one, no visible change, no change. Let me go ahead and write those last two in the chat and then we'll move on. All right, I hope we're good. Feel free to stop me or ask a question. Our next test solution is magnesium sulfate, MgSO4. Let's add some HCl, some hydrochloric acid, and see what happens. Okay, here's the resulting mixture. But now you can be sure there's no precipitate here. This is just a solution. The tube hasn't gotten warm or cold, so there's been no heat change. I don't smell anything coming from the tube. There's no bubbling, no gas forming, no change of color, no formation of precipitate. So no visible change that we can see between MgSO4 and HCl. All right, the next one, ammonium chloride, NH4Cl. Let's add some HCl and see what, can y'all predict what's gonna happen here? Since we have a common chloride ion between NH4Cl and HCl.
It's going to stay the same.
Exactly, it should stay the same. They have an ion in common, so even if they do a double displacement reaction, the combination of ions is still the same. Look, we were correct. No visible change. All right, let me write that down again too. Just to make sure. I don't know who can hear me at this point. Just to make sure you have all the information you need. Okay, our next test solution is water. I want someone to make another prediction here. Do we think anything's going to visibly change when we add HCl to water? When we add an aqueous solution, that is, of HCl to water?
No, ma'am.
Please don't call me. Please don't call me ma'am. All right, let's see if we're right. All right, I don't see anything. Do you all see anything?
No.
Nope, no change here. Don't worry, I'm always checking for other changes. If I smell, if I perceive a scent, or if I see any bubbling or anything like that, I'll let you know. But from where I'm standing, no change here either. All right, let's try our unknown A. And I'm about to add some HCl to it. See what happens. All right, I'll let you decide what's going on your own. Okay, got it. All right, with that, we're done filling in all the cells in that first table. Do we have any questions before we move on to part B? Any questions before we move on to part B? No, okay. All right, so for part B of this experiment, nothing has changed in terms of which test solutions and which we. So we still have the same 5 test solutions. One is one is NaCl, two is NaCl3, 3 is BDSO4, 4 is NH4Cl, and the 6th one is the unknown. And we have the same reagents, the same 3 reagents, NaOH, but I put the order, and I'm calling them ABM. We're gonna do all those experiments again, combine them just like we did before. You write down your observations, then compare those observations with the ones in the first table. See if you can figure out what reagent is going to be what. Okay. Also, the unknown is different this time as well. So that's a fun little twist. Oh boy. All right, let me have a look at that table. All right, we're gonna go across the table just like we did before. I hope y'all can see. The audio is going in and out. Oops. Are you muted? All right, so let's start off with reagent A. I have it right here. So let's add some reagent A to solution 1, which is NaCl. Okay, can you see that? All right, so this time I'm not gonna spell out what the observations are. Hopefully you can see what's going on. All right, so this is solution 1 with reagent A. I'm not gonna be writing it down, so look up and have a look at it and write down your observation. I'm not gonna throw it away yet, so if you miss something and we have to go back, I'll pick it up again and show it to you again. Okay? So this is solution 1 with reagent A. All right. Here's solution 2, which is Na2CO3. And I'm adding some of reagent A. Here it is. So this is solution 2 with reagent A. We all see that? I hope we all see that.
Yeah.
Okay, good. All right. Do I have solution?
Excuse me.
Yes.
In the boxes for the experiment for region A and stuff, do we just write down the observation? That's all we're doing?
Yes. Just write your
Okay.
observation.
Okay, sounds good.
Is that you who just asked about the grouping? Someone wants to know if there's a grouping for this class. So if anyone knows, and you can paste the link in the chat, that'll be real nice. Did I already do? I just did this one. That's more just to be sure. You have an observation for it already? Solution 3, region 8. Okay, here's solution 3, and I'm adding some region 8. Oh, a lot in this tea. Stir, stir, stir to make sure everything's combined thoroughly. Here's the result. Here's the resulting mixture. Write down the observation. Again, this is solution 3 combined with reagent 8. Solution 3 is magnesium sulfate, MgSO4, just to help you keep track. MgSO4. All right. Here's solution 4, ammonium chloride. Let's see what happens when we add some reagent 8. All right, here it is. If you can't see or you want me to close up or something, let me know. I can show you the bottom of it too. I can show you the meniscus if you want to see the bubbles. Just let me know. All right. Here's solution 5, which is water. I'm adding some reagent A to it. You should already know what's going to happen here, but I have to do it sure. There it is. Solution 5 plus reagent A. Okay. Now here's our unknown B. It's a different unknown than in the first set. And I'm about to add some reagent A. All right, here it is. Unknown B, our second unknown, plus reagent A. This is what it looks like together. Okay, so that was reagent A. Let's move on to reagent B. All right, so we have the same 5 test solutions. Here's solution 1 with reagent B. I hope we can see that. Here it is. Solution 1 with reagent B. This is what it looks like. Okay. Solution 2, sodium carbonate. Let's add some reagent B, see what happens. All right, here it is. So you write your observation for this solution 2 combined with reagent B. All right. Moving on to solution 3. Let's add some reagent B, see what happens. All right, here it is. Trying to get the black backdrop there. Let's have a look at the bottom of the tube. This is what it looks like. Can you see the bottom of the tube? All right, we have our observations. This is solution 3. With reagent B. All right, got it. Here's solution 4. Let's add some reagent B, see what happens. All right, here it is. Here's the bottom of the tube. Here's the whole thing. All right, that's solution 4, which is ammonium chloride, I believe. Yep. With reagent B. All right. Here's solution 5, which is water. And I'm sure you can predict what will happen. So this is test solution 5, which we know is water, combined with reagent B. This is what it looks like. Here's the bottom of the tube. I don't see any solids settling there. So you write your observations. We got it? Okay. Here's unknown B again. Let's see what happens when I add some reagent. All right, here it is. You can see. Here's the bottom of the tube. There's nothing there. I don't see anything. I don't know if y'all can see this bubble here, but it was already there, so don't pay it no mind. All right. So we've done the second room. The first and second rows. Last but not least, let's try reagent C. Yes? All right, here's the solution 1, which is NaCl. Let's see what happens. Reagent C. Sorry? Well, that is solid dispersed throughout it. But I do also see something at the bottom. All right, here's the resulting mixture. This is solution 1, which is NaCl, reacting with reagent C, which is either, what are the three again? AgNO3, NaOH, or HCl. It's one of those. Look closely at the bottom of the tube here. I hope you can see what's there.
Which solution is this again?
This is solution 1,
Okay.
reacting with reagent C.
Oh, okay.
Okay. All right. And I was saying, I don't know if y'all can see what's going on at the bottom of the tube there. I'm trying to show you. All right. And here's what it looks like. This is the mixture. Okay. Let's move on to solution 2, which is sodium carbonate. We're going to add some reagent C. It's not really settling. Okay, here it is. Trying to give you a real close up this time. So there's like little flakes floating throughout. But if I stop shaking it, I'm going to stop shaking it for a minute. And the big pieces of solid, they're sinking down towards the bottom. So I hope you can see at the bottom here, there's a lot of white solid. That's what I'm seeing. But this solution is like, well, not solution. This mixture here, it's pale white. And if I shake it up again, it'll all just be floating around. All right, we got that? Read our observations? Again, this is solution 2 combined with reagent C. All right, so we're almost done going across that last row of the table in part B. Let's keep going. Solution 3. Let's add some reagent C and see what happens. All right, here's the result. This is the resulting mixture of solution 3 combined with reagent C. Here's the bottom of the tube. Anyone's curious? Here's the resulting mixture. You write what you observe here. All right. Moving on, solution 4, which is ammonium chloride. Let's add reagent C to see what happens. All right, here it is. Here's the resulting mixture between solution 4 and reagent C. Reagent C. This one's completely opaque. It's not pale like the previous one. I like to use milky to describe this one because it really doesn't look like milk. And here's the bottom of the tube. I don't know if you can see, but there's some white solid at the bottom there. If I were to stop shaking it, I could probably get more. But we got something really milky white here. So you write your observations. This is for solution 4 mixed with reagent C. All right, okay. Solution 5, which we know to be water. Let's add some reagent C, and we should already know what's gonna happen. I'm gonna tell you, you don't have to tell me. We just have an understanding, yeah? We know it's coming. So you write this observation here, if there is any observation to write. Ultimately, this is not gonna help. This one here is not going to help you figure out what reagent C could be, because it's just water. Water is gonna do that with all 3 reagents, but it's still important information. All right, so we see it, hopefully. Nothing at the bottom of the tube here. We've been predicting what will happen when water dilutes an aqueous solution. So you write your observations here. Solution 5 for solution 5 combined with reagent C. All right, last but not least, here is our unknown B. So remember, the unknown from the first table is different from the unknown in the second, this part B table. All right, let's add some reagent C, and C, what happens? Don't. Okay, here it is. This one looks similar to the previous one that was white, except there's a lot of solid at the bottom, if you can see that. And I can see the solid just falling and falling to the bottom. But here's what the resulting mixture looks like. All right, and this is unknown B with reagent C. It's like actively sinking. If we just let it sit there for a couple minutes, a lot more. All right, I think that was the last one. Yep. The recording? Yes. It'll be a YouTube link so you can watch it over again. On Blackboard, it'll be posted as a YouTube link so you can go watch it there. All right, so everyone, you all should have the top table in part A completely filled out and the table in part B also completely filled out. So we went through all of those reactions. Do you all have a line that says under the second table in part A? Do you see a line that says sample number of unknown for part A? Do you see that?
Yes.
Yes.
You can write A there. I'm calling it unknown A, so you can write A there. So that line under, that first line under the second table in part A, where it says sample number of unknown for part A, you can write A. That's what I called it, unknown A. And then in part B, under that table in part B, you can call that B, unknown B. That's what I call it. Okay, so you're going to use all of your observations, the formulas for all the precipitates that formed, to determine what's the compound in unknown solution A and what's the compound in unknown solution B. Then there's some questions after that, and you do the rest for your report. Questions. So we're done with the experiment. If anyone wants to see any of the tubes again, if you missed anything or something wasn't unclear, let me know. I haven't thrown away anything yet. Just let me know.